All right, well, welcome all. I'm going to present to you today some success stories in cloud native computing. This is a talk that I have not given, so you guys are my first brand new set of slides here that I'm excited to share with you. Let me introduce first the company. So we are Ampere Computing. My name is Sean Varley. I'm Chief Evangelist for Ampere Computing. And we are a modern semiconductor company that is building for sustainable cloud. And we've built essentially the first cloud native processors in the industry. And now we see that category picking up in momentum. And what I thought I'd share with you guys today really is customer success stories and the case for moving to these cloud native processors. Essentially, why should I move? What should I move? And then, of course, how should I do it? And I will try to get through this in 15 minutes. Okay, so the time is really now for us to kind of look at this sustainable computing. If you look worldwide at the trends in electricity and in space and in overall data center build out, we're seeing global challenges. Across the world, we're seeing geographies that are limiting data center space, new build out. Of course, this is because of actual electricity availability, but also because there is a shortage of space. I just came back from a tour of APAC, and many geographies there are space limited, and they're really trying to fit more compute into a smaller footprint. And moratoriums and lots of kinds of regulations continue to abound. So we're seeing this kind of pressure put on the data center suppliers in all quarters to really get more with less. And if you look at the kind of global carbon emissions outlook, we're seeing, of course, data centers picking up a bigger and bigger share of the overall emissions. This is one statistic, but by most statistics, it's anywhere from 2.5% to 3.5% of global carbon emissions, just the data centers themselves. You know, really similar to other more well-known industries like aviation or shipping or some of the agricultural industries. So our architecture is fundamentally about efficiency. This chart shows you what you should know about cloud native computing. It's basically twice the performance at half the power. And if you do the math on that, that's a 4x potential theoretical advantage by using a cloud native processor to do your computing needs. We don't do many of the things that our competitors do in the x86 industry. We don't do turbo frequency, we don't do hyper-threading, and we don't do scale-up accelerators inside the chip. So what we're about is really an optimized infrastructure. We scale out with cores, we're single-threaded cores, and we actually have a really, really power-efficient core, so we use those to best advantage for cloud-native workloads to be able to execute every process in that containerized thread, which is a really apropos kind of way to look at it. Containerization is a trend that's kind of sweeping all the cloud native industry. And this is something that we do very, very efficiently. Along with our architectural shift, we allow people to scale linearly. This is a huge piece of our advantage because we put all these cores into a processor. We want you to use them, all of them. That means we execute at 90% plus utilization for our processors. That's very different than the way you've seen the x86 ecosystem do it. We're also about general purpose cores. So we use the accelerator interface through PCI Express to add best-in-class accelerators. We kind of have a philosophy that you don't put that inside the general purpose processor because it clutters it up, adds power, adds die area for things that are only needed in niche markets. Okay, so we have a broad product portfolio now, scaling from 32 cores all the way up to 192 now. We're just releasing new data this week on the 192 core processors. So you should definitely check out our webpage for the latest information on the performance of that 192 core processor, or check us out in our booth. But here's just a kind of snapshot of the difference. I don't have time to go through all of this, but maybe picking out some highlights. You know, we are kind of building on the feature set of single-threaded cores with consistent frequencies and large L2 private caches. This is the foundation of cloud-native computing. We also are now adding on to that with the Ampere 1 line new features that will continue to build out the value proposition of what a cloud native processor is. This is around performance consistency with the ability to do memory and mesh congestion management and quality of service, but it's also about scalable management, being able to detect failures, being able to kind of do something about them as the processor ages, but also security. Security is a very, very important thing, as most of you know, in the cloud today, and we've actually built in new tagging features. These are features that are not carried in the x86 ecosystem. This is the ability to kind of really isolate again those containers or those VMs that are operating on a multi-core processor. So just some contrast around cloud native computing. So really, a cloud native application is contrasted from a legacy application in all of these ways. Now, I'm not going to read all of these off for you, but to think about it in simplistic terms, a legacy application is more monolithic in design. It's less portable, maybe has some more OS dependencies, and also maybe licensed by cores, but it really has difficulty in scaling. And that is a fundamental piece of what the cloud native value proposition really gives to this industry. So the cloud native application is distributed, it's microservice by design, it works interactively and independently with all its co-processes, and it's orchestrated. Kubernetes is kind of the poster child of orchestration in the container industry, and that's what these processes were built for. Very, very dense processes all working together to return a result. This scales easily with cores, and it makes for a lot less sensitivity to latencies and SLAs, all right? So that's kind of the contrast between these two types of applications, and I'm gonna get into what should you move. So you start in the web tiers. Web is everywhere. It's in every infrastructure, and it's front end, back end, in-memory caching. All of these types of things are cloud native by design. They all have assets that are now ARM compiled and compatible. And so you have easy access to applications in this industry. I'll show you some of those applications in a moment. Then you can move into some other scale applications. What are scale applications? Video services, or now AI inference. These are the kinds of applications that are going with web infrastructures to build out modern web services that are very, very dynamic. Think of every application on your phone or every business-to-business application that is running in the world today. They all have elements of these things, and video is, of course, a major piece of the internet traffic in the world today. Finally, this is now shifting all to the edge. This cloud-native architecture is being pushed into everything from autonomous vehicles to smart factories to smart cities. All of these kinds of things are starting to take this new mode of operation, this really container-orchestrated mode, into all of those infrastructures as well. All right, so a scale web service is our example today. We have analyzed the scale web service for basically the capacity needed to process 1.3 million requests per second. And we ask ourselves the question, how many servers or racks are required to do that? We look at the 4 tiers of that web service. Nginx is the front end, Redis, the key value store, Memcached, the object store for large objects, and MySQL at the back end. And you can see the measure of efficiency here, the difference in the Ampere cloud native design. More than 4x for Nginx. Why? Because it's a very cloud native application. But all the way down to MySQL, where it's about 2x. Why? Because it's more I/O bound. And so the I/O comes in and starts to limit the effectiveness of using all those cores, but you still get a nice boost. So the result of my 1.3 million requests per second model experiment here is that you can get about 2.5x better performance per rack using the Ampere cloud native architecture. And that really kind of translates to about 36 CPUs, which is 1 rack. And that actually translates into a much bigger savings in power. So 2.8x in power, as you can see, contrasted here with the major competitors in the x86 ecosystem. We're using a mere 12.7 kilowatts, which is about the power of a single rack in the world today. It's an average. Racks range all over the place, but they're usually in that 10 to 14 kilowatt range. And so this translates into space savings. I'm coming back to the fundamental value proposition I talked about earlier, space and power. This is how you fit more and you get more for less, because you can save up to 1/3 of that rack space by utilizing this cloud native architecture difference and the advantages that I've been talking about. Now, you might ask yourself, do I have to implement this entire thing? The answer is no. You can actually convert one application, and that application doesn't really care what it runs on. At the API level, it runs on everything. And so you can convert just one application and get a huge benefit. In fact, this is the way it actually should work, because let's not kid ourselves, every infrastructure in the world today is on x86. All right, so you have a multi-architectural environment. Embrace it. That's the way that you should do it. Convert one application at a time, and actually you can see the benefits. Here's the benefits of just replacing the front end, which I'm highlighting here, that Nginx front end architecture. The benefit can be up to 11 kilowatts, and again, 1/3 fewer servers. Look at the Nginx example here. I'm cutting from 35 down to 12 servers, or 20 down to 12 servers, and that can save you that massive amount of power. This OpEx savings translates year on year into continual savings over the course of the lifetime of the product. That 11 kilowatts can then actually turn into 68 tons of CO2 saved, or $22,000 per year on about 20-cent cost of electricity, which globally is, on the lower end. In some countries, it's much, much higher than that. All right, so who's using this stuff? Plesk announced with us that they had converted over to a couple of our cloud partners in the world, and that actually has benefited them by converting many customers of their integrated web services stacks into real world differences. It's actually getting 40% better price performance. All of the case studies I will share with you today are up on our website at the link that I'm showing you there, or you can go up on our website. It's pretty easily findable. Let's talk about Redis, one of those applications that I shared with you just a moment ago. Redis is very scalable, and you can see here how it's scaling out linearly against an x86 competitor, and that headroom that you're getting out of that 90% utilization is significant. If you look at the right-hand side of this, we're looking at predictability. As you scale something up, eventually applications kind of fall over a cliff and they get kind of jittery, and that's what you're seeing in that chart on the right. That is very stable and linear, again, with an Ampere cloud native architecture. So we had a partner of ours, Momento, which is a serverless cache provider, do a study on this on GCP, and they showed 31% better performance. And of course, this is going to come with an even bigger benefit in price performance if you look at the prices of the instances that Ampere stands up in the cloud today. On the cloud, since we're on it, all of these applications are running on multiple different clouds. Here's some data from Microsoft Azure. This is a pretty significant savings. What we did is we compared using these applications together, and we kind of took a cloud spend of $34 million annual budget. We're able to save those customers with that type of a spend in the cloud $7.7 million or $11.7 million just by using the price performance of these cloud native instances that are hosted by Azure. Amadeus was one of the first customers on the Microsoft Azure cloud to actually do this. And you can see here their experience, which actually mirrors the data I showed you, 37 to 50% better price performance. This is real value in the world today. Okay, let's talk about AI for a moment, and I've got a very small amount of time to talk about it, so I'm not going to belabor this with details. So AI, of course, is a big topic in the world today. We have a strategy. It's really about open frameworks, software acceleration, and getting to disruptive performance. You don't have to have a GPU to do inference. So GPUs are kind of the go-to solution, but we actually can do this with scale-out processors better for performance per watt than a GPU server. So here's a couple of quick slides on that. Again, I can't spend a ton of time on this, but the models that you can utilize here are diverse. You can get into all of the recommendation engines in the world today, DLRM. You can get into the large language models, BERT. And we're showing you here, again, performance per watt, 3.8x or 3.6x better than other architectures in the ecosystem. That carries on to Gen AI models. Whisper, ResNet, all of these models are significantly better performance per watt than the competition. So again, we have many case studies on our website, Lightly and Matoha here, showing again the value of these things. And you can kind of go and check out some of these case studies on our website. The link is here. Lightly, Matoha, Wallaroo, and Elotl are also doing a lot of this kind of work with us and showing the benefits of scale-out, GPU-less AI inference. Okay, I'm going to end on a case study that I actually really like because it's different than the ones I've talked to you about. Nogales Lab is a electron microscopy, a cryo-electron microscopy lab at the UC Berkeley. And one of the things that they did was when they actually converted to Ampere was they actually looked at this and they said, oh, I just need a lower power server because I'm kind of running up against the budget of my data center. There's a lot of servers that service these microscopes. And what they did is they put in 1 Ampere server to begin with, and immediately they saw the results. You can see here 60% less power, a 40% better compute efficiency, but get this, one of the things they were experiencing on that again, this is a microscope that's sensitive to temperature, was they were going through shutdowns quite frequently with their microscope because of the heat in the data center was overheating their equipment. When they converted to Ampere, all of that went away. So that's why I ended on this particular case study, because it kind of shows the power of moving even 2 servers out of their data center to an Ampere architecture, completely changed the game for them for that particular application. All right, how should I move? I'm put up a bunch of links here. You'll be able to get to this content, of course, on the OCP website after the show. Many different assets on our website to be able to help you. Come to us if you think that you have a need for this type of technology. We'd be happy to help you out. Enjoy this show. I'm really appreciative of your guys' attention today. And be sure to visit our partners in their booths as well as our booth here at B28. We've got live demos running, many of them on AI, and we're also showcasing some of the things that we're doing on Ampere 1 today. I appreciate your attention.